Big hello to everybody. I'm just going to do a bit of a run through on this generator. It needed a name, so I'm going to call it the EGG. It stands for Energy Expansion Generator. So yep, now it's got a name. I've been experimenting with different flywheels or rotors, if you'd like to call them. That's a little one from a previous experiment that's on there at the moment. My previous video you would have seen I was using this one here, which I managed to get the current draw down to about 1 milliamp. As you would have seen, it was also driving some LEDs. I've put some bigger LEDs on here now. They're 2.5 volt 30 milliamp LEDs. This is a bigger flywheel I made. It's got 19 by 25 N52 neodymium magnets in it. I've tried that, it does work, but it's not as efficient as the smaller rotor. I think the magnets are too big, they're saturating the core, so we'll leave that for a bigger project. So what I've done with this one now, hooked it up as per the Bedini SSG setup. We've got a run battery here. 12 volts, 7 amp hour battery. Our charge battery is the same. As you can see, it's coming from the positive of the run battery through the caps, hooked up to the negative of the charge battery, and then our high voltage leads going to the positive on the charge battery. The other thing was with this rotor here is I went to a 240 volt neon because the 110 volt one blew out. This one actually blew out as well. Nice pretty blue flashes, and then it was no longer. So what I've done now is I've put two of 240 volt neons in series between the high voltage and the collector, sorry, the emitter on the transistor. So hopefully they will be alright. So what I've got here, this is the battery voltage on our run battery, our amp draw from the run battery, and that's the current voltage on the charge battery. It's fairly flat, so that will give us a good indication that the system's actually charging. It should go up reasonably quick to start with. So a run through on the schematic for it. Comes from the run battery through a diode down into the run coil, and that's the start of the run coil. The end of the run coil goes straight to the collector. No diodes, nothing, just straight to the collector. The high voltage comes from the collector through the diode as per the SSG into the charge battery. The trigger coil as per SSG goes straight in, the start goes straight into the potentiometers or pots through a 270 ohm resistor into the base. I've also got a diode from the base to the emitter as per the SSG. This is only needed if you're going to be charging batteries. If you want to run the power back on to the run battery, as in the previous video, you don't need that diode, but if you want to charge batteries you need it. So it makes no difference, you might as well put it on, then you can do both with it. The coil is set up that it's got the trigger windings are wound on there first. There's 4 layers of 0.355 copper wire on there, and then over the top of that is 8 layers of 0.71 for your run coil. So what we'll do now is we'll fire it up. This goes a lot quicker with this little flywheel or rotor. There's something different about this too, which I'll show you a bit later on, another advantage of this system. So we'll fire it up. It does go quite quick with this rotor on. Just slide up a little bit. Okay. Now, two little LEDs. Well, they're blinking that fast now you can't even see that they're blinking. The amp draw there is 65 milliamps. And as you can see, the battery voltage is going up. The other question I've been asked is, well, what about the high voltage spike? Is it still there with that setup that I've got? Well, hopefully I don't blow these globes out. So we'll disconnect the charge, and as you can see, they light up. So, and keeping in mind that's two 240 volt neons hooked up in series. So I'm not sure if you need 480 volts to fire them up being hooked up in series, but if I use only one, it blows straight away. So as you can see, works quite fine in the Bedini charge setup. It is getting a high voltage pulses going to the battery. Now the battery is climbing. So we'll turn this off now. I just wanted to show you this flywheel. That's good for the fingers. Okay, most of you will know that with the SSG, the common way to set them up is all north out on the magnets. You can do them south out, they do work. Not quite as efficient because it's actually working back to front if you do it like that. This one here, as you can see, we've got a south magnet there, and north there, south there, north there, and so on. They're alternating. And the reason it works like this is because when a south magnet approaches the coil, the way that this system's wired up, it'll actually fire the transistor and pull the magnet to the centre of the coil, because the coil's designed to fire north out the top, south out the bottom, of course. When the north magnet comes around to it, it won't fire the transistor until it starts to leave, so that actually gets pushed away from the centre of the coil. So your south approaches, gets pulled towards it, and then the north starts to leave and gets pushed away from it. So it doesn't matter which way you've got the magnets orientated with this setup. It will work with the 3 on the north, or 3 north on the top, 3 south on the bottom, 1 south, 5 north. It doesn't matter which way you set it up, it will run, and it will run just as good in any configuration with the magnets. So that's another advantage of this system here. You lose no efficiency if you get some of the magnets wrong. So very good and simple setup for beginners with very good results. In my next video I'm going to show you, with a couple of extra bits added onto this, how you can power 240 volt light globes for your house should the power ever go out. So the schematic for this I'm going to draw up, post on the TEEP forum, hopefully sometime today if not tomorrow. and anyone that's interested in building it and giving it a go, you'll probably get the good results like I'm getting now. Till next time.